So hello, I think I'm live. First time doing this with OBS Studio, and it looks like it's not working. Okay. So I need some feedback. Is the sound okay? Can you hear me? And can you see Storm in the background? Maybe some of you can join on Discord, so we have a little chat. So it's a bit lonely here. Cool. Yeah, for some reason in Discord, I'm streaming that to Discord at the same time, but the image is mirrored. I don't know how to solve this at the moment, but yeah, I think I just start if everything is fine so far. Okay, for today I thought we make a little project, and I thought about a cigarette. We have maybe particles falling down while the cigarette is burning, and maybe some smoke. And yeah, maybe, I don't know how it's called, a holder for the cigarette, a bucket. Yeah, and I think I will start to do that. For that, I just start with a read node and load a cylinder, transform that, maybe half the size, double the width, and turn that into a volume and just blur it a bit. I'm not sure how I can have the chat always on top. Yeah, I need a second monitor, a second screen. But yeah, first time today, so maybe it's going to be better next time. So we create a second copy of that. Make that a bit smaller. Maybe a bit higher up. Always like to do that with typing in the numbers, but you can also summon some controls with W for translation, R for scaling, and E for rotation. Maybe I do it, and then make a difference. Shift X will switch the inputs, and I hope we get this yeah, bucket thing. Maybe we copy and paste this blur to get round edges. And then we need this little holes. An ashtray, okay. Little holes, and yeah, I just save the scene. Ashtray. We also start with a cylinder. T for transform, and make this super thin. And rotate it. Just can grab the right one. Now I have it. So, and I need a cube. Maybe we can combine that at this level and scale it all together. So something like that. And merge that to one stream. Turn that into a volume, and another difference to cut that out. Switch the inputs, and yeah, almost. That looks fine. And we just rotate it and merge it again before the mesh to volume node. So we have these holes. Then we can maybe to resample to increase the resolution. Do a filter to blur it a bit, and was the wrong one, and hit M, mesh to volume. We need volume to mesh. Okay, here it is. I always tend to disable the adaptivity. And yeah, not really pretty, but yeah, we can work on that, I think. So maybe we lift that up a bit. And maybe less blur to get sharper edges. I think that will do it for now. We use that as a collider later. So I save and create a write node. if we replace the ABC to OBJ, we will write OBJ instead of Alembic. And when we remove these hashes, we just get one file and not a sequence of files. So I just look into the chat. Are there any questions? I don't see any, so I just proceed. Okay, we're hitting the simulation button, and now we have the whole thing written to disk. Okay, new scene. Now we create our cigarette. For that, we again use the cylinder, and yeah, make it a bit slimmer and also taller. So maybe, yeah, that's a very short cigarette, maybe a bit thinner. Yeah, that's looking better. So yeah, I'm no smoker, so I don't know. Yeah, is that a good length? Maybe a bit shorter. Something like that looks fine to me. Just save this thing. So first we want to create some particles. So we hit M for turning it into a volume, and then add a scatter node and set that to grid layout. Now we have our cigarette in particles, and we want to simulate that with a granular system. So we add one to the scene, but now we need to get these particles into the system. For that, we create import and export system nodes. And choose the granular particle system. Connect that. And now we can use the emit node to emit into this system. And right now, let me enable that, and we need to turn off the visibility in the classic system. When we start that, it explodes, and that has several reasons. The first one is we are emitting on every frame, so we want to have that only on the first frame, and we can do that with a little expression. If the frame F, frame is whole frames, and frame F is all the substeps as well. If that is equal to the start frame, $start frame, then it will emit. So now we have only the first frame. And we have it, the particles are below the ground. So we have collide ground enabled though. So the particles below the ground will just fly away. So we need to reposition that with a transform node. So maybe something like this. And if we now start the simulation, our particles are emitted and falling to the ground. So what are we doing Next. One option is, so what I have in mind is a cigarette in this, I can load that too, maybe for reference, or ashtray. So here's the ashtray, maybe a bit small. What I have in mind is a burning cigarette in this ashtray. And the ash is falling into the tray and smoke is rising up. So maybe something like that. By the way, if we are at it, we can just add this ashtray as a collider. For that, we have several options. I'm just thinking about what is the best one in this case. I think we remove that from here and just add a collider to the granular particle system and load the ashtray there. I think that works best in this scenario. There it is again. And now you can just test it. Yeah, it's falling in the ashtray, but also collides with the ground. You can disable that for a moment. So yeah, that works. Save that, have a look at the chat. No questions, but for viewers, great. So what we want now is that the cigarette stays in place and the particles are becoming loose the more it burns down. So first thing we can do is, I just delete this one, is to make it stable so it doesn't move in space, and we can do that with another collider. This time we take this cube and disable collisions, but we enable stick strength, the stick feature. So we type in 1 and also enable transform stick, because that is a bit, or that is more stable than doing it without transform stick. So we move it this way and just make it big enough that it's bigger than the cigarette. Okay. And if we now start the simulation, nothing is happening, or the particles are not sticking. And that is because we need a stick attribute. So we create an attribute set node, name to stick, scalar type. Scalar is, it only uses the first row, and vector uses all three of them. We only need one value from 0 to 1. 1 is full stick, 0 is non-sticking at all. So we are turning that to 1 and just throwing that here in the loop, and look what's happening. Yeah, it's sticking. It doesn't go anywhere. So now we need to unstick the particles to make them fall down. And the cool thing is we can have this state of the cigarette. You can see both the transformed particles and the original ones. And we can alter attributes here and transfer that onto these simulated particles. So what we want is an attribute like a burn attribute which starts at one side and slowly grows until everything is burning. So I just disable some of the elements to have a better view. The ashtray, this one, and the collider is not important too. So to do that, we start with the attribute set node. And to see something, we have to change the color. So we use the color attribute CD, and that is a vector for red, green, blue. So if I hit 1, everything is becoming red. So one thing I do first is raise it above the ground plane. I think that makes it a bit easier. I have just to look it up how tall it is. So, no, that was not enough. Strange. Sorry. Okay. So now the first row is at position y0 and the last one is at 2.5, which does make it a little bit more difficult because it's easier to calculate between 0 and 1. So we just scale it. So 0.4, and now I think it's 1 meter tall. And to make it a bit more pleasing, I just do it on all axes. Are there some questions so far? Is the speed good, and is it understandable what I'm doing there? Yeah, I guess so. So what we now want is an attribute which is growing from bottom to the top. And there's an easy way to do it and a more sophisticated one. The easiest would be to create a maybe burn attribute and compare the current position, the current frame with the position of each particle. So if I type at p.y, that is the position, the y position of every particle, and subtract that with the frame and maybe divide that by, don't know, 100 to get smaller values. Just remember we have the particle y position is 0 till 1, and the frame starts already with 1 or 0. So we only need a fraction of this value. And then we can just have a look how that looks by converting this burn value, you can see it here, into a color. So if we type in at burn, we get this gradient, and it should move if we scroll the timeline. So now it's the other way around, but I'm actually not sure how. It's the right way. Okay. So I save that. So I think now the gradient is far too wide. We need to make that smaller. So we can remap that. This value, we know it's from 0 to 1. I have to try it out. Now I flipped it. I just have to try it out. I'm not sure how I did that. Okay. Yeah, okay. You can remap that, so the values here can be clamped with the first two numbers, and that the last two are the target. That is the source. So we say even we have values between 0 and 1. We say we clamp that on 0.5 until minus 0.5 to 0, and we remap that to 0 and 1. So we still have 1 and 0, but it's clamped. Hope that is you can understand that. So one problem with that is you always get a linear motion, so it's burning the same speed every time. I have no experience with cigarettes, so maybe it would be cool if it burns faster and slower, but that's difficult with this setup. But maybe we just leave it like that for the moment and enhance that at a later point of time. So what we can do now is transfer these values to our simulation. So if I just take the color, and you can see color is set by default. We transfer the color attribute into this dynamic simulation, and we transfer by default ID. We don't have IDs, so by index. So the order of the particles, you can here is the same as in the dynamic simulation. So the first particle here is the same as the first particle here, and so on for every particle. So when we now start that, you can see that this color attribute is coming over. It's the wrong way, but you can see slowly the color is changing. So we can reverse that if we just change the values here in the remap node. So, nee, no. I want that, but from the other side. How I do that? Quick fix would be to just rotate that by 180. No. How about now? No. Now I have rotated it the right way. That's, by the way, cool. You can always type in just some equations in these channels and Storm will calculate that for you. But now what we can do is do something based on the color. So we inserted this stick value, and if you remember, if stick is 1, the particle will stick. If it's 0, it will not stick. So we can type in expression here and just type in if the color is red, the color red is greater 0.5 or something like that. So if it's red, smaller. So if the color is not red, it should stick. Hope that works. Nothing's happening here. Sometimes I have to think about it. If it's red, it should be 0. So if it's not, or actually greater than, if it's greater than 0.5, no, smaller, it should not stick. This should be true. We can just have a look. We have some. Okay, there's it's doing, some things are becoming loose, but maybe the constraints are too strong. So maybe remove the constraints at all for the moment. Just now it's sometimes maybe it's after that. Okay. Yeah. So sometimes the order matters. So maybe it started and set the stick to 0 because the color is set at this point. And yeah, I think it's working better now. So the particles are becoming red and falling down. Okay, that's cool. But maybe it would be cool to have more, chunks, or do you know that when a cigarette burns down, the ashes are not falling down, but if you just snip it or give it a push, then it all falls down. So maybe we can get some effect like that too. So we reset that, just test what's happening. Okay, now the particles are sticking together. and are falling down. Yeah. Okay, cool. But maybe we can give that a bit more variation. And we can do that with an up attribute called max stretch. It's also scalar. By the way, you can look them up on the website in the docs. Max stretch will set, it's basically an attribute which controls this break stretch value, but per particle. So we can put that here and turn our color value into the stretch value. By now that won't give much different results because the red is very uniform. But maybe we can add some variation with the noise. So we go back to this state and just add a noise. And this will transform or add noise to the position and the velocity. We just turn that down, but now we get a noisy velocity. And we can use that to add some noise to our to our attributes. So connect that. And now I think we want this value 1 now altered by the noise. So we can now just type in length, or just type in at point x, for example, and now we get a random or the noisy value for the velocity, but use that to drive our burn value. And something is happening, but I guess the noise is also going in the negative direction. So we have very big values going minus, and we can have a negative color. So we need to make that positive. And we can do that if we normalize this value. If we just divide it by the length, also the so the how strong the vector is, and nothing is happening. Okay. Yeah. So we can see all the values are negative, so we can't see something. Now we get something. Okay. Here's our noise. Just make the particles a bit smaller. So, okay, it was working, but not at the beginning, of course, because it's growing down. And the noise is moving all the time, so we type in, here's the seed or the phase, just make a static value. And find a good value here. Here we can see a lot, and maybe add more noise. So if we now play the simulation, the timeline, it's not all static, but yeah, we get this noise. Maybe I increase it even more. And I do think we just don't need the, zero value, a value of 0. So we can remap that in this expression. So remap (0, 1) and maybe 0.8 and 1, and maybe it works. Yes. So now we have the noise, and it's growing from black to red, but not all reds are equally red, but there's some kind of variation going on. So now we have that. We can use that to drive our max stretch value. So again, we use a remap to remap the burn, or not the burn, the red channel. Okay, we actually we can do it here too. Was a bit unnecessarily complex to do it in here. So maybe go back to 0 again and just try it here. Have a value of 1 and a bigger value like 10 maybe for the other parts, and just to see what's happening. So okay, we have to turn them bigger again. So now you can see the red particles are falling down, are breaking apart, and the black parts are staying where they are, but that's also because of the attribute we made here. Maybe so they are sticking at the moment. Maybe if we just no, we can't do that. How we solve that? We can transfer another attribute. I think that would be best. So we just transfer the burn attribute. I think you can make this smarter, but yeah, I'm not sure to do it now. So now we are also transferring this burn value we made here. So I hope So the burn value is turned into a color here. So maybe we need another stream. And remove this stuff. And hope now it works again. Okay, it's falling down, but is it also more chunky? I'm not sure. Just have a look at our max stretch value. We have very high ones and then very small ones. Maybe I can make the initial one a bit higher. Yeah, I think I made a mistake at some point. Don't know if I can solve this. What I can do is to load the scene I prepared earlier, but I think I don't want to do that. Yeah. Maybe we just remove that and maybe are satisfied with this result for the moment. I think I can solve this now, but we can play with this value a bit, maybe lower that these are breaking apart more easily. And maybe also increase the stiffness, so this wobbly behavior vanishes. Yeah, okay. I think I leave it at that. We have to revisit that at some point. But we have not much time left, and I want to do some things more. And the first one is to show some procedural modeling in Storm. You can add a particle width attribute if you have to solve this problem. Here are the particles too big in the simulation, they are too small, but you can also just add this attribute and type in a number to give them a good size. So one thing I want to add is a paper rolled around the cigarette, and for that we start with the grid. That is just a plane, and we can use the set attribute node to roll it. So for that we manipulate the position. So if I hit P, all the points, all the vertices of the mesh are set at 0 position. So we want to give them a new position, but in a circular way. So the that should stay as it is. So p point z. You can see anything. So if we just type in p point x, now everything is back to normal. This is always the current value for each vertex. So to roll it, we can use a sine function based on the position x. So now we get this cool shape, but yeah, we need another dimension. We just type in the cosinus of px, and now we have a tube. And yeah, now we can go to the grid and up the resolution, and you can see it gets much rounder and maybe also more resolution here. So that's great. You can see here is a strange part. Looks a bit strange, and that is because the grid is too large, I guess. So it's curling multiple times. To have that fixed, we just type in 2 pi, and now we have the correct length for that to make only one turn. So we can now just steal this transform node, I hope. But first we need to line up this one. So just add a transform node, 90 degrees, scale, what we have, 10 meters. Just do it here by eye. Okay, and no, that was the wrong one. So make that fit. So 0.4 seems to be a good value. And now we have our transform, which is just a copy of this one. So we just have that in the right direction. And now we can transfer the color from our simulation. There are two ways to do that. One is we just take it from the export system, but we can also add a clone node and put it somewhere. Oh, okay, that just went on vacation. And now we have a copy of the dynamic particles which we can use to do other stuff. So we just transfer the color, and now we do it by proximity. So now the color is transferred to our mesh, but we can't see it because Storm can't display these colors on meshes. So we just for visualization, we just convert these into points and just have a look if that worked. So you can see, maybe we need more range. Aha, okay. So you can see particles here turning red. That is our mesh. And we can use that if we write that out. I think we will write that later. That is just an attribute, a color attribute we can use to do the shading. In Octane we can easily access that with a vertex attribute node. But I guess in other render engine that's the same. So we have the particles, a paper around it. Now we need some smoke, and for that I just write this simulation and use that in a new scene. So, okay. And I will write that as well. So save and simulate. Are there any questions? Is that logical what I'm telling you? So the particles are written out. I start a new scene and I just load my particles. So here are the particles, and now we want to add some smoke to it. And for that I don't want to emit smoke from the not burning particles, and I don't want to add smoke from the burned particles. So I guess we need just the ones in the middle. For that we add a delete node and check if the color X, the red color, is smaller than 0.3. So if we type that, all the black particles are gone, but we still have the fully burned ones. So we need another condition, and we want them to be true at the same time. So double and. We also want the X to be the CDX greater than 0.6 maybe. So that was wrong. We want, because that condition is not true for any particle, we want to have an OR. The node should delete if the X is smaller than 0.3 or greater than 0.6. So now we only have the part which is burning at the moment. So next we can just add a basic smoke graph. Where is it? Oh, there. Come on. So by default, this will emit smoke from this box. We don't need that, so we can delete that. We want emit from these particles, so we had P to turn them into a volume. I always like to turn that into a fog volume and emit from that. And I think I always use run procedurals on subframes for this, and 2 subframes. I think that gives the best result, and also increase the substeps here. Yeah, and let's see how that looks. You can turn them on. So now you can see it's a lot of smoke for a cigarette. So yeah, that it's a lot of fire. We need a more subtle smoke. So yeah, maybe way less density, and maybe actually just have a look how that looks. Maybe way less heat. And you can also, I think we need more heat. Don't be fooled by the red color. It always looks like fire, but yeah, you just, if it's helping, you can also add a volume scale node in the end and scale down the temperature to maybe 0. And then we don't have that anymore. Maybe it's a bit easier to find out if the result looks like you want it to be. And of course the resolution is a bit coarse, but yeah. Maybe let it fade more quickly, and the heat not so fast, and more vorticity to get a few more swirls. And I think I'll try more resolution. Also have to up this here as well. Can also add a bit of noise to the particles, only to the velocity and a curl noise, but only just a little to have yeah, the initial a variation on emission at the beginning. And of course the cigarette is burning very fast. I could imagine this would take a lot more time to actually burn down. And yeah, just for visuals, we can also load in our ashtray. And the, oh, I think the animated mesh didn't, it didn't write the mesh sequence, so yeah, you have to imagine how that looks. But yeah, I think now finished. We can write our caches and hop over to rendering. Yeah, so I'm done. Hope. Oh, there are a lot of comments. Yeah, I know. I know it's not the right smoke, but yeah, I think you can play with it. I will share the scene afterwards, and you can try to get better smoke out of it. I think maybe it needs to be hotter. I'm not sure. So I'm not sure what happens if you add more noise. That's too much noise. Curl noise is always very strong. Oh, and it crashed. Sorry. Yeah, I think it's yeah, over now. I hope you liked it. I hope the recording worked, so we can rewatch this at a later point. And yeah, see you next time. Bye bye.